Good morning, students. Till now in previous classes, two parts we have discussed. One in the first part we have seen how to calculate sensible heat, and then latent heat calculation separately we have discussed. Now in this class we are going to solve problems where both sensible heat and latent heat combined calculations will be there. That we will discuss with help of one case study, like enthalpy changes during phase transfer accompanied by sensible heat changes. Okay, enthalpy changes means nothing but the quantity of heat, is it to be supplied or to be removed, that only is the enthalpy change, Q. And Q during phase transfer, when there is phase transfer accompanied by sensible heat changes. So this heading we will discuss in detail with the help of one example here. Say first like two cases we will discuss. First case example is consider water at 30 degrees centigrade. Okay, consider water at 30 degrees centigrade. We want to convert this to steam at 150 degrees centigrade. Okay, we want to convert to steam at 150 degrees centigrade, because in chemical industry, suppose if you have water at 100 degrees centigrade, okay, if you want to convert to steam at 100 degrees centigrade, steam, then what is this? This is nothing but lambda, latent heat. That's what we have seen in the last class. But who will start the steam production operation at with water at 100 degrees centigrade? Normally we take room temperature. Water at room temperature we take. Okay, we take water at room temperature. Then we go on supply heat. Then ultimately we will stop the operation when steam reaches 150 degrees centigrade. Okay, that is the operation we want to do. Then in order to in order to obtain steam at 150 degrees centigrade with reference to water at 30 degrees centigrade, what amount of heat is to be supplied? That is our question. So here directly you can't calculate. Okay, there are several stages that should be applied here, that we will see. First we have water at 30 degrees centigrade. We have this. Then this should be heated to and here you should know that boiling point of water, this we know is equal to 100 degrees centigrade. We should keep in mind that phase change takes place. That means steam production from water takes place only at 100 degrees centigrade. So first we need to heat this water. We need to heat this water to 100 degrees centigrade. Okay. This is water at 30, initially what we have, then we need to heat it to water at 100. Here the quantity of heat to be supplied is Q1. So you can say Q1 is equal to heat to be supplied to heat water at 30 degrees centigrade to 100 degrees, again water only here, 100 to water at 100 degrees centigrade. Okay, this is also water, this is also water. This is Q1. Now still continue supply heat. What happens? This 100 degrees centigrade water will be converted to water vapor. Okay, steam, you can say steam at degrees centigrade. Okay. So this will be converted to steam at 100 degrees. Water at 100 is converting to steam at 100 degrees centigrade. Let it be Q2. Okay. So Q2 is equal to heat to be supplied to convert water at 100 degrees centigrade to steam at 100 degrees centigrade. Okay, to convert water at 100 to steam at 100. Now we have steam here. Then this steam should be converted to steam at 150 degrees centigrade. Steam at 150 degrees centigrade. Let it be Q3. So Q3 is heat to be supplied to convert steam at 100 degrees centigrade to steam at 150 degrees centigrade. Okay. So 3 stages we have here. 3 stages. First stage, second stage and third stage. So what is this calculation? Each stage calculation is different because here temperature is changing but phase is not changing. Here phase is liquid phase, here also liquid phase, but temperature is changing. So here you need to take a sensible heat calculation, mCpm dt. So this is what calculation of sensible heat. Sensible heat. Okay. Next, Q2. Here water is at 100, steam is at 100. Temperature is not changing, temperature is remaining constant, but phase is changing from liquid phase to vapor phase. Okay. So this is what now latent heat. This is latent heat. This takes place at what? Here it takes place at boiling point. Okay. This takes place at boiling point, this Q2 phase. So what is the equation here? M lambda V. That is the equation to calculate Q2. Now again come to this third stage. Now we have steam at 100. This we want to convert to steam at 150. So here also vapor phase, here also vapor phase. There is no phase change but the temperature is changing. So this is what calculation now, sensible heat calculation. Okay. So this is again what equation? mCpm dt. That is the equation. Here M or N depends on units of CPM and lambda V. That we already discussed in last classes. Okay, like that. So water at 30 is, we want to convert from room temperature water to steam at 150. So what is the quantity of heat to be supplied? You cannot calculate in a single stage because in between some phase change is there, phase change is not there. So you need to divide into stages. So from 30 to 100 there is no phase change. First stage. Second stage at 100 to 100 only. Liquid is changing to vapor, that is steam. So second stage, latent heat. Third stage here, temperature is changing. Same steam is being heated from 100 to 150. So this is again a sensible heat. Therefore, the total quantity of heat to be supplied, total quantity of heat to be supplied supplied equal to Q, this one. This Q is what? This Q from 30 to 150. So Q is given by here, add all the parts, Q1 plus Q2 plus Q3. Okay, each part you need to add. So here sensible heat calculation is there, latent heat calculation is there. That is what here, enthalpy changes, Q is nothing but enthalpy change between 30 to 150. That means the heat content here in this stage, heat content here, the difference of the heat content is nothing but enthalpy change Q. Okay, that is calculated in 3 stages, and finally we are adding all the 3 parts. That is what enthalpy changes during phase transfer. This is phase transfer here, accompanied by sensible heat changes. Here sensible heat changes. Okay, this graph, if you draw a graph, how this will look. Here. See here, if you draw here, temperature, here heat supply. If you want to show in the form of a graph, how this will be, initially temperature is 30 somewhere, so you will get a line up to here. So let it, this is initially 30 degrees centigrade. Now this will rise up to 100 here. Okay, this can be 100 degrees centigrade. So here water at 30 degrees centigrade, and here water at 100 degrees centigrade. So first water at 30, as we go on supply heat, temperature rises from 30 to 100 here. Then what happens at 100? It does not change. That is, you can draw like this, a straight line. Okay, this is what. Now this is steam at 100 degrees centigrade. Here it is remaining constant. Again here it is changing. Okay, this is what. Okay, this is what temperature? 150 degrees centigrade. This is what now? Steam at 150 degrees centigrade. Okay, like that we will get here. Initially we have taken water at 30. We are supplying heat. Then its temperature will rise till water reaches its boiling point, that is 100 degrees centigrade. That is boiling point equal to 100. At 100 only here latent heat. So this is say here Q1, and this is after reaching here, there won't be change in the, no change here in the temperature, only phase is changing. Here water, here steam. So this is, let it be Q2. We got steam. Here phase is not changing. Here also steam, here also steam. But temperature is changing. That is, let it be Q3. So these are the parts now. Therefore here Q is equal to Q1 plus Q2 plus Q3. Okay. So this case involves both latent heat, phase transfer means latent heat accompanied by sensible heat. Okay, we will see another example, that is this time we will take latent heat of fusion here. Okay, so consider ice at 0 degree centigrade is converting to here steam. Shall we take steam at 150 degree centigrade? Such a big case we are taking here. Means we want to change ice at 0 to steam at 150. Then what is the enthalpy change, or what is the amount of heat to be supplied? So many stages will come here. The very first stage is what here? So here ice at 0 degree centigrade. Next, this should be converted to first water. Water at 0 degrees centigrade. Ice at 0 need to be converted to water at 0. This happens at melting point. So okay, melting point of ice equal to 0 degrees centigrade. Here latent heat of fusion takes place here. Now this water at 0 is to be converted to water at what we need to convert to steam. That means first 0 degrees, from 0 degrees till 100 degrees centigrade it can exist in a liquid form. Here liquid form, here liquid form. No phase change, but temperature is changing here. So then after 100 degrees, water at 100 is to be converted to steam at 100 degrees centigrade. Then this steam at 100 degrees centigrade is to be converted to steam at 150 degrees centigrade. Like that, ice at 0 is converting to steam at 150. Let this be Q1, Q2, Q3, Q4. Okay. So here, and this is happening at a melting point, and this is happening at a boiling point, that is 100 degrees centigrade. This is at 0 degrees centigrade. Okay. So here what? We have taken ice at 0. First stage, actual operation is at 0. Ice we are taking, we are converting into steam. What is the total amount of heat to be supplied? We cannot calculate in single stage. We need to divide into different stages, with phase change, without phase change, or sensible heat calculations, latent heat calculations. So first you take ice at 0, convert to water at 0. Here this is latent heat calculation. Okay, latent heat. So this is M lambda F, latent heat of fusion, because solid to liquid. And here then liquid at 0 is there, that need to be heated to 100. This is sensible. Okay. So this is M CPM dt. Then Q3. What is Q3? Water at 100 to steam at 100. Okay. So this is again latent heat. This is again latent heat. Okay. So this is what? M lambda V here. Here lambda F, here lambda V. Then sensible, this is again, because here also steam, no phase change. So sensible M CPM dt. Okay. So here CPM means heat capacity of liquid in the liquid stage. Please understand the difference between this CPM and this CPM. Okay, when this is in the liquid form and when this is in the vapor form. So this slightly different value you will have. Okay, therefore what is the now total heat to be supplied? Total heat to be supplied equal to Q. So Q equal to 4 stages we are calculating. Q1 plus Q2 plus Q3 plus Q4. 4 stages. Here, like that sensible heat calculation, also latent heat calculations, both are involving in single problem. That is the enthalpy changes accompanying during phase transfer, accompanied by sensible heat changes. Okay, next class we will solve another 2 classes. We will solve the actual problem. Here simply we have discussed the concept. The same type we will have to solve some another 2 problems. Thank you.